Well, good afternoon, everyone. I'm Dan Hewitt from the Office of Communications, and welcome to NASA's Johnson Space Center. We've gathered here today to make an announcement on the future of commercial resupply launches to the International Space Station. As you can see, I am joined today by Ellen Ochoa, the director here at NASA's Johnson Space Center, Sam Shamimi, the director of the International Space Station Division at NASA headquarters, Kirk Shireman, the International Space Station Program Manager, and Julie Robinson, the Chief Scientist for the International Space Station Program. Now, each participant is going to make opening remarks, and then we will open it up for your questions, first here in the room, and then for those on the phone. With that, I'll hand it over to Dr. Ochoa to kick it off.
Thank you. I'd like to welcome you all to NASA's Johnson Space Center. That includes everybody in the room, as well as those of you watching on NASA TV and listening to us on the phone. Thank you for joining us today for an important announcement. NASA is committed to advancing human spaceflight, and our team here at Johnson is at the heart of that mission. To achieve the seemingly impossible, we must be lean, agile, and adaptive to change. This philosophy is applied to every facet of human spaceflight that we touch today, from the International Space Station and Orion to the various technology development programs that are laying the groundwork for our journey to Mars. Today's announcement focuses on the International Space Station, which for more than 15 years has served as a laboratory to advance scientific knowledge that will enable future exploration and benefit the lives of people on Earth. A lot of work is done by many talented people, both inside and outside of NASA, to make sure we get the most out of this one-of-a-kind facility. The space station remains a blueprint for global cooperation, with partner space agencies around the world working toward common goals of space exploration. And a new commercial space market is continuing to take shape, a robust destination for commercial scientific research, technology development, and human and cargo transportation. With that, today we are announcing the next chapter in the public-private partnership with American companies to ensure that NASA maintains the capability to resupply the space station from the United States through 2024.
All right, thank you, Ellen. And with that, I'm going to hand it over to Sam Shamimi. Again, he is the Director of the International Space Station Division, all the way from NASA headquarters, joining us here today in Houston. Thanks, Sam. Over to you.
All right, thank you, Ellen and Dan. First of all, it's good to be here in Houston today to announce the awardees for CRS-2. 7 years ago, when NASA announced the first ISS cargo resupply contracts with Orbital and SpaceX, we introduced a new way of doing business that takes advantage of the strengths of the American aerospace industry and the fixed-price commercial services contracting. To date, our CRS-1 commercial providers have delivered over 35,000 pounds of research, crew, and maintenance hardware to the space station. Though it has not been easy by any measure, both our CRS-1 providers have experienced launch failures and are in the process of recovering. NASA and our industry partners have learned valuable lessons from these failures and the recovery to flight. As we look forward to continuing commercial cargo missions to the space station, we are also working with our commercial crew industry partners to deliver American and international crew members to the space station from the United States. By taking advantage of the U.S. industry strengths and leveraging commercial contract mechanisms, NASA is able to focus its resources on expanding human presence into deep space, including a journey to Mars through cislunar space. Commercial cargo, along with commercial crew, are major elements in enabling the growth of a low Earth orbit commercial market opportunities, both on the supply and the demand side. A little bit later, Julie will highlight the research that has been enabled by turning over access to low Earth orbit to private industry. The National Lab, via CASIS, has been able to take advantage of the access to space station that commercial cargo providers have provided to really expand the private and non-government, non-NASA government use and research on board the space station. Now, I'd like to announce the CRS awardees, if that's all right with everyone, in alphabetical order. First, Orbital ATK of Dulles, Virginia, Sierra Nevada of Sparks, Nevada, and SpaceX of Hawthorne, California. These contracts begin upon award, each contract guaranteeing a minimum of 6 missions. However, as of today, we have not yet ordered any of those missions. Through these multiple awards and the contract delivery flexibility and indefinite delivery and indefinite quantity nature of these fixed-price commercial services contracts, NASA and CASIS will be able to take full advantage of this amazing international endeavor, the space station, to meet NASA and the nation's goal in exploration and the development of the commercial market in low Earth orbit.
All right, thank you, Sam. Now we're going to go to the International Space Station Program Manager, Kirk Shireman, so he can share more details and the service options for these contracts. Kirk?
All right, thanks, Dan. It's great to be here this afternoon, and it's really a pleasure to make these announcements and get on with the business of the International Space Station. The Source Selection Committee carefully evaluated all the proposals. Based on that evaluation, the selection official chose the proposals to provide the best value to meet NASA's requirements. And those requirements allow us to resupply the space station through the year 2024. I want to emphasize the reason we're here is not just to talk about the contracts, but also to talk about what these contracts enable. It's really important. It's very, very important that we continue on the work that we're doing on ISS, and these contracts will enable us to do that. Science and research in that unique laboratory that only we can explore outside of the Earth's gravity. The ISS will allow us to advance humans' presence deeper into space. All these things really are enabled by these contracts. We use the knowledge gained from our CRS-1 or Commercial Resupply 1 contract and applied that knowledge to our requirements for CRS-2. When we awarded CRS-1, we were learning how to operate the ISS without a space shuttle. Of course, we'd been flying the ISS for a while with the space shuttle, and it took us a while to learn the new contracts and how to write them appropriately. What we learned was a lot of times we actually volume out, was what we say. We actually will fill up the volume of these Commercial Resupply 1 vehicles, but not really use all the mass capability. And so we've added a requirement in CRS-2 so that we will measure both the volume and the mass and use these vehicles more efficiently. CRS-2 vehicles allow the delivery of larger amount of cargo in a single flight. Basically, it's reduce the total number of missions. That's important for a couple of reasons. One is it's more efficient in terms of our crew time, and that's a precious resource aboard the ISS. When the crew's unpacking and repacking cargo, that's time that they're not spending doing research. Also, it's important basically because comings and goings of vehicles is really time intensive, just monitoring the approach and departure of the vehicles. With the CRS-1 contract, we issued task orders when the contract was awarded that provided a dollar figure for 20 metric tons of cargo. That was the original requirement in CRS-1. CRS-2 contract's a little different. We have more mission types, which allows us more flexibility. And it'll take us all some time to determine the right mix of flights and missions to meet our needs. So again, we haven't issued any task orders yet, but we'll begin to work with the contractors, the awardees, to determine which missions best meet our mission needs in any given year. Another key difference about CRS-2 is an insurance requirement to cover damage to government property during launch services, reentry services, transportation to the vicinity of the ISS, and also actually docking and undocking from the ISS. We added additional constraints on milestone payments to ensure that sufficient progress is being made on station integration before we award those milestones. CRS-2 will also require cargo processing pre- and post-flight. NASA provided a single set of requirements for resupply services, but offerers were allowed, first they were required to meet those requirements, but they were allowed optional capabilities and mixing them in a manner they choose. Basically what happened is offerers were allowed to bid different types of missions in order to meet these requirements. Each company's missions are unique, and that's one of the great things about this contract. NASA can select any mix of missions from those companies' offerings that best meet ISS missions or ISS requirements for a given year. The capabilities include the capability requirements were 2.5 to 5 metric tons of a pressurized up mass, pressurized down mass of 2.5 to 5 metric tons, and that's down mass recoverable or also down mass disposal, or some combination of both of those things. It also required an unpressurized up mass and disposal capability. As mentioned, in conjunction with the mass requirements, the vehicles need to have a minimum pressurized cargo density of 65 cargo transfer bag equivalents per 1,000 kilograms of pressurized cargo. The space station requires approximately 4 resupply missions annually, with the cargo distributed throughout the year. Resupply must be provided, must be spread out for numerous reasons, including space available on the ISS, supplies, launch dates, meaning there's multiple vehicles, not only these cargo vehicles, but also crewed vehicles and cargo vehicles from our other partners. Time commitment from the crew, and like I said, traffic to and from the International Space Station, which again, it's other vehicles, but it's also port utilization. We only have a few ports for berthing and for docking. And finally, and most importantly, to support our scientific needs aboard ISS. Packing supplies aboard the ISS is really a time-consuming process, and there's no one there but our astronauts, who are also our researchers, to accomplish these tasks. That means that we're taking, anytime we're packing and unpacking a vehicle, we're taking away time from the valuable research and utilization we do on ISS. Therefore, we wanted to be as efficient as we could with that process. So let's talk about some of the specifics of the proposals. Orbital ATK, in their proposal, they offered 3 standard missions. 2 missions provide pressurized cargo delivery and disposal, and 1 provides unpressurized cargo delivery and disposal. The pressurized cargo missions offer 2 variants on different launch vehicles, 1 launching from Florida and 1 launching from Virginia. All missions from the Orbital ATK proposal berth to the International Space Station. Sierra Nevada proposed 2 standard missions. Both of these missions provide pressurized cargo return and disposal, as well as unpressurized cargo delivery and disposal. These missions, both types of missions, launch from Florida. One of the missions has the ability to dock to the ISS, and the second has the ability to berth to the ISS. SpaceX proposal offered 2 standard missions. Both provide pressurized cargo delivery and return, as well as unpressurized cargo delivery and disposal. The missions both launch from Florida. 1 mission type docks to the ISS, and 1 mission type berths to the ISS. With all that in mind, it brings us to cost. The total cost paid under the contract will depend on which mission types are ordered. When we're ordering these services based on our current estimate of the space station needs, and like I said previously, it really provides a flexibility to NASA and the International Space Station program to order up the type of the mix of pressurized, unpressurized, return, and disposal that we need at any given time. While we do not anticipate expending the total value of the contract, the indefinite delivery, indefinite quantity type of contract enables us to adjust as necessary for additional missions or contingencies, and it provides the greatest benefit to NASA so that we can fully utilize this great asset that we have in space. Missions and prices vary depending upon how we order, how many we order, what type we order, and when we order. As an IDIQ contract, we have the flexibility we need in order to order the missions a la carte or in groupings, whichever we choose, which makes it impossible to give a specific cost at this date. Each mission is complex and requires several years of lead time. The lead time was also in the proposals. Discussion and engineering assessments will start very soon, leading to integration work to the ISS later this year, and we want to make sure that all the ISS requirements are met. We expect the first missions under CRS-2 to begin in late 2019. After we've had time to debrief all the companies that submitted a proposal, we'll be able to provide you with additional details, including making the source selection statement public. The ultimate goal of CRS-2 is to ensure that we maximize the use of the International Space Station as a national laboratory by providing supplies and services to the International Space Station. We want to dispose of unnecessary cargo and return back the necessary research and cargo that we need back to the ground through the years 2019 through 2024. This will ensure that we keep the International Space Station fully stocked for crew, enable people like Julie, our chief scientist, and her team, and private industry, other government agencies, and including our international partners to fully utilize the ISS as a laboratory. This laboratory, the national laboratory portion, is run by CASIS, and they're a big part of how we utilize ISS. And again, the flexibility we have with this procurement will allow us to make CASIS and their use of the national lab successful. We look very much forward to working with Orbital ATK, Sierra Nevada, and SpaceX in the future. Thanks, Dan.
All right, thank you, Kirk. Now we're going to turn it over to Julie Robinson, who again is our chief scientist for the International Space Station program. Julie?
Thanks so much, Dan. Every day, NASA and our partners conduct extensive scientific research on board the International Space Station. But that research needs to be delivered to the space station and in some cases returned to the scientists back here on Earth. We rely on commercial resupply service providers for that transportation. Our experience with CRS-1 has shown how important our access to the station is, not just for NASA, but for the wide array of companies now taking advantage of the station's role as a U.S. national laboratory. Working with our commercial resupply partners, as well as the Center for the Advancement of Science in Space, CASIS, managers of the National Lab, has led to new users from the commercial sector, academia, other government agencies, and even other countries taking advantage of the space station's facilities. The new requirements will ensure the companies chosen for CRS-2 will maintain the flexibility required to meet the demands of space station research, including the ability to continue to fly unpressurized payloads, things like the Bigelow Expandable Activity Module, or BEAM, going up later this year, and various Earth observation instruments like the International Space Station RapidScat, an instrument looking at winds, as well as maintaining the ability to return research samples and hardware back to Earth. The option to provide an accelerated pressurized return as part of any standard mission, which means that a sample return could be in 3 to 6 hours after landing instead of 24 hours, is a huge advance for a number of different research disciplines and one potential service about which we're really excited. CRS-2 resupply missions will also overlap with our commercial crew program, which will enable us to add a 7th astronaut to the space station, significantly increasing the amount of crew time we have to conduct research. The CRS-2 companies will deliver that important cargo, as well as the research and the supplies for the additional crew members. We, and that is the scientific community that's not limited to just space science, but extends to physical science, biological science, earth science, astrophysics, and more. We learn every day from the research conducted on the space station, and we use that knowledge in ways that benefit humanity. Some benefits are immediate and tangible right here on Earth, and some pay dividends by enabling us to continue exploration, moving humanity deeper into space and inspiring us all. We all should be thrilled at what today's awards mean to ensuring all of this good work continues so that we can get the most out of the space station while maintaining the flexibility necessary as we continue to expand the community of scientists and researchers using our space laboratory.
Okay, thank you, Julie, and thank you again to all of our briefers. Now we're going to open it up for questions. Just a reminder for everybody on the phone, if you have a question, you need to press *1 to get in the queue, and then you can press *2 to withdraw your question once you are in there. Please keep in mind that, as with any NASA procurement, the selection rationale and additional details will be released at the appropriate time in the future. I ask that everybody sticks to one question for now, since we do have a high volume of people waiting to ask questions. And then if we have time at the end, we'll go around for follow-ups. As always, please start off with your name and affiliation. I'm going to start off in the room going left to right like I always do. Robert? He's obviously been here before.
Hi, Robert Perlman from CollectSpace.com. It was mentioned the lessons learned from CRS-1. Can someone comment on how, if at all, the recent launch failures played into the decision to pick 3 providers and to give you that option of after experiencing 2 providers being grounded?
So I guess I'll take that question. So first of all, the source selection is based on a number of factors. One of them is past performance, and so and a failure certainly factors into past performance. So in that sense, it was considered in our selection of the offerers for this particular procurement. But you're right, one of the considerations from an operational standpoint from ISS, it's really important to have more than one supply chain, and having multiple offers means at any given time you could have the sequence of flights could be one, Sierra Nevada, SpaceX, Orbital ATK, and so you have the ability to, if you lose one, you have the ability for another one being right after it from a dissimilar redundancy or a different supplier. So that's a big help to us. Now, all of these vehicles have different capabilities, so it's not like buying a commodity off the shelf. There are differences and there are impacts associated with it, but that's certainly a consideration that we thought about even in developing the procurement and selecting the various winners of this particular procurement.
Eric?
Eric Berger with Ars Technica. In some ways, getting the second contract is harder than getting a first contract. The fact that you're here 7 years later, it kind of validates the commercial approach. You've done cargo, you're doing crew. Just kind of wondering, in a big picture, as NASA looks to partner further with the commercial sector through the fixed price contract, what's the next step? Is it, habitat modules, heavy lift? I mean, where do you sort of see commercial partnership sort of progressing?
So I'll take a shot at that. Well, and then maybe Sam has one of the things we're trying to do with ISS through cases is foster a low Earth orbit economy, and so where we have the opportunity to achieve that goal through commercial contracts like this that are fixed price, that I think you'll see it continue. It's hard to sit here and enumerate exactly what those are, but we want to make sure we get the best value for the government, for the American people, and we also want to make sure that we're achieving our goal of fostering a commercial economy in low Earth orbit. So absolutely, you will see more as time goes on. What those specifics are, it'd be hard for me to answer specifically. Sam, if you'd like to add.
Yeah, that's really good, Kirk. Well, what I would say is that as we move forward, not only what comes after space station, but as we move human spaceflight beyond low Earth orbit into cislunar space, we're looking at ways and means to develop the commercial market and just U.S. industry in general to achieve our goals. So like Kirk said, we haven't made any definitive decisions about what's traditional development, what's commercial development, but we're looking at all those possibilities, and we're leveraging the station we have today, like Kirk said, to enable the commercial market, not only just on modules and spacecraft, but the way we do business in low Earth orbit, and also in developing the commercial demand, which is even more important than just the commercial supply as well.
Gene?
Gina Sinceri, ABC News. Julie, you talked about a seventh astronaut. What are the complications with that, and how do you get them there? And you have to have three lifeboats. Talk to me a little bit about that seventh astronaut and why it's important.
So of course, the technical reason we don't have 7 astronauts today is that each of our lifeboats holds 3. And so you can't efficiently have lifeboat capacity for 7 crew members. So once we have commercial crew, that will allow both transportation of 4 crew members up to the space station as well as return of 4 crew members in a lifeboat function. And so that's what lets us bring the space station to its actual original design, which was to have 7 crew members. From a research perspective, it's enormous because then all we have to do is bring a few extra supplies for the crew to sustain them while they're on orbit, and we get basically that whole additional crew member does nothing but research in all of their time. So it makes a big difference for the amount of research that we can do on the ISS, for our throughput, if you will, and it makes an extraordinary difference for some of the really hot areas that we're seeing a lot of commercial companies, like pharmaceutical companies and other organizations that are interested in doing research on the space station. It really enables the kinds of research that they do, which sometimes are very intensive.
Okay, we're going to go to the phone now. And again, if you are on the line and you have a question, you need to press *1 to get into our queue. Let's start off with Alan Boyle of GeekWire. Alan?
Thank you for taking the question. I wanted to ask a little bit more about Sierra Nevada and the plans to use the Dream Chaser. I just wanted to make sure that one of the options does call for the spacecraft to return to Earth. I think that's what Julie was referring to with the capability of getting something back in 3 or 4 hours. So if that's the case, could you talk a little bit about the effect of having this new type of spacecraft, a winged spacecraft, in the fleet, and what it means for science and what it means for the perception that people might have of the space effort? Thank you.
So, well, let me start off a little bit. So, yeah, Sierra's proposal does have a vehicle returning. Actually, it returns to Earth and lands. Both types of missions that they offer, the difference of the types of missions really has to do with its interaction with the space station on orbit. And so it lands. You can get cargo off very, very quickly, which and Julie can comment on that from a scientific standpoint. It also has a milder return profile, so which also might have benefits. So we have the ability of looking at that possible return versus the other types of return that we have. So that's important. And finally, again, a dissimilar redundancy. We talked a little bit about that. We have the ability to dial up that capability if one of our other capabilities is unavailable to us.
Just to add a little bit about what it means scientifically, right now we have biology studies that are going on the space station, and we bring home live organisms. When those organisms come home, if they have a really hard landing, a splashdown, then they're at sea for a couple of days, you've really disrupted that before the scientists can take their final set of measurements. So that rapid return, return plus 3 hours or return plus 6 hours, is really valuable. And the soft landing is also valuable. It also matters for some physical sciences samples and things like protein crystal growth experiments where the hardness of the landing could actually disrupt the samples. And so this is a really nice capability to add to the suite of things that we have available.
Okay, let's go to Jason Rion with Spaceflight Now. Jason?
Hey, this is Jason Ryan with Spaceflight Answer. Sorry, I'm having a hard time getting off my speakerphone. My quick question is, given that you already have 2 participants under CRS-1, what dynamics can we expect to change on station besides the addition of the 7th astronaut, and how much did the budget request play in NASA's ability to add this 3rd partner? Thank you.
So I would say the real issue with respect to having 2 are our lessons learned in CRS-1. The big issue was we want to make sure we have a robust suite of vehicles that go up to ISS. We're also, one of the considerations, as I mentioned before, is also fostering a low Earth orbit economy. That's an important consideration for us. And so all those things kind of fit into why why it makes sense to have 3 providers. So we're looking very much forward to having all 3 companies provide their capability. In terms of what happens at space, I think it's not so much the individual vehicles as it is the fact that we're carrying more cargo on each vehicle. Therefore, in aggregate, we're going to have fewer vehicles over time coming to the ISS, and that helps because the crew has to, believe it or not, dockings and undockings or berthings and unberthings are critical. I would say I'll call them dangerous. They require risky. They require the attention of our crew members. So we have to set up all the equipment necessary to support a docking or a berthing, and we have to monitor it with our crew members. And the same is true with undocking and unberthing. And so having fewer of those allows us to actually use more time for research. And finally, the different types of missions, some of them are docking and some of them are berthing. And the beautiful thing is we'll have 2 docking ports and we'll have 2 berthing ports. And so the different types of missions allow us to fully utilize all those ports. And it's flexible, the way this procurement is flexible enough that we can dial those in as the mission sequence and our requirements dictate.
All right, let's go to Gotham with Cowan & Company. Gotham, go with your question.
Yes, thank you for taking my question, and congratulations. Hey, I was wondering if you could comment on how quickly you would anticipate issuing initial task orders given the lead times for the missions. And secondly, will each mission be competed, each task order be competed among the three going forward?
So our plan is to begin working with the companies immediately. Certainly we'll start working with them and doing engineering assessments. It's certain to us exactly when we'll issue the first task order for ISS integration, but we anticipate that later on this year. And we expect the first flight under CRS-2 to be in late 2019. And that's okay. I mean, from an ISS perspective, operationally, that's okay. We have flights under CRS-1 that will allow the ISS to be productive all the way through that time period. So the meshing of CRS-1 and CRS-2 looks like it's going to work out really well. So, well, again, like I said, we'll begin working with these companies immediately on their CRS-2 flights, but the task orders might follow later this year.
Okay, next up we have Bill Harwood with CBS News. Bill?
Yeah, thank you. Kurt, and I just want to make sure I understand the scenarios fully, but you're saying all three of these contract winners can deliver cargo, pressurized cargo and unpressurized to the station, but they can also bring it safely back down to Earth. None of these are designed to burn up, or am I missing that? And also, you said docking and berthing, so I'm assuming any vehicle that docks would go to the IDAs on Harmony, Zenith, and forward, and that any berthing mission goes to Unity, Nadir, and Harmony, Nadir. Is that right? Thanks.
As always, your knowledge of the ISS impresses me, Bill. First of all, no, all the cargo vehicles, all of them can bring up pressurized cargo. All of them, and when I say all, each company has the ability to bring up pressurized cargo. Each company has the ability to bring up unpressurized cargo. The only ones who, and all three companies have the ability to dispose of cargo, both pressurized and unpressurized. However, Sierra Nevada has the ability to bring home cargo that's recoverable. So when we talk about science samples that Julie was mentioning earlier, that there are only two options for that are Sierra Nevada and SpaceX. So those are the two options that have recoverable pressurized down mass. None of the vehicles provide unpressurized down mass. So it's a little, I realize it's a little confusing and I apologize for that, but it's confusing to have this press conference, but it turns out to be really great flexibility for us to execute the International Space Station program. So, and that's one of the great things. We have these dials, if you will, and we can by choosing the various companies and the various types of missions from each company, we have the ability to manage our risk and to get the right amount, the right balance of disposal of cargo versus recovery of cargo.
Okay, next up we have Ken Kramer with Universe Today. Ken?
Hi, thank you, and thank you for doing this. I wonder if you could talk a little bit more about SNC. I'm wondering, did you pick them specifically because they can land on the runway in a few hours, or is it more to have the redundancy with with a third cargo provider? And also, can you provide an update on the next mission or two that you're planning to the ISS? Thanks.
So we actually picked them because they had a great proposal. So, but the details of the source selection will be made public here in the near future. So I'd rather defer that until the source selection is made public. In terms of operations on the ISS, we are currently working with SpaceX on their next mission to ISS. We call it SpaceX 8. They call it Falcon 9-23. We typically let those companies announce the launch date, but I can tell you we're in constant communication. As was mentioned, they're first of all recovering from a mishap. Number one, and number two is the Falcon 9. The type of Falcon 9 that we're flying is also a new vehicle, a new higher thrust engine and stage. And so not only are they recovering from the incident, but they're working through basically modified vehicle. So they've flown that once. They flew it in December very successfully, and as you probably noticed, they landed the first stage back on the ground in Florida. They're looking at the data. We're actually the third flight of this full thrust rocket. So Falcon 9-23 or SpaceX 8 is the third flight of this new type of rocket. And so we'll let SpaceX identify the launch date, but we're working with them, and it certainly meets our requirements. Orbital ATK is going to fly, and we call it OA6. So it's Orbital ATK 6. Will launch from Florida. Right now, the launch date from that is March 10th, and that appears to be on track. The Orbital 5, which I apologize for the way we number things, but is the subsequent orbital flight, and it'll be out in the summer time frame. We don't have a definitive date on that, and that flight will be on an Antares 230 rocket from Wallops Island. So I can tell you right now, things are going really well on orbit. We're preparing for a spacewalk tomorrow, and we're prepared to have SpaceX 8 and Orbital ATK 6 arrive to the space station here in the near future.
All right, next up we have Irene Klotz with Reuters. Irene?
Hi, thanks very much. I have a couple questions for Kurt. Do these CRS-2 contracts have the IDIQ have a maximum value similar to the $3.1 billion that the CRS-1 contracts had?
So the contracts have, in aggregate, the procurement, the RFP that we sent out had a maximum value of $14 billion. I can tell you that the mix of flights that we're looking at is nowhere near that value. We don't expect to get anywhere close to that value. But from a federal acquisition requirements, we have to put a maximum contract value, and that's what was put in the request for proposals. There is a minimum number of missions to ISS in each of these contracts. So there is a minimum of 6 missions from each of these providers. So, again, I talked about it in my opening statement. There's no way to give you a good exact cost of what we expect, but like I said, it won't be anywhere close to the maximum contract value.
Okay, next we have Frank Mooring with Aviation Week. Frank?
Thank you. Kurt, just to continue on Irene's question, what's the nominal performance time for that big number contract? How long will you be doing the CRS-2 missions, at least from the beginning? And also for Julie, is there any science that you can't do now that will be enabled by this Sierra Nevada capability of soft landings and quick unloading?
So let me do mine, and I'll pass the buck to Julie for her question. But the intent right now, the law of the land and our authorization, NASA's authorization bill is that ISS is up through 2024. All the international partners, with the exception of ESA, have also agreed to go to 2024. ESA is having their ministerial meeting, which is where they would take such action in December of this year, and we are looking forward to positive results from ESA. So, as I said earlier, we expect the first flight to be in the latter half of 2019. ISS is authorized in the United States through 2024, and that would be the period. Again, one of the benefits of this procurement is there's going to be enough room between what we actually expect to pay now and the maximum contract value, that should ISS be extended, or should we need a significantly larger number of flights than we think right now, we'll have plenty of room to do that without having to adjust the contract value or go out. It won't force us to do another procurement. We'll certainly have the option to do another procurement at that time frame. None of those things are definitive at this point. I'm just telling you what our options are relative to what we would happen out beyond 2024 and beyond.
And to give you some examples of the kinds of science that we can't do today that we will be able to do, there are a whole bunch of different aspects of this new contract that are really appealing for science. But the big one that stands out to everyone is the R+3 or R+6 return, that return within 3 to 6 hours of the samples to the scientists and within 3 to 6 hours of landing. And some examples of some things we can't do today, definitely all the things that we're doing with living organisms. Some things don't matter as much as others. So we have a live rodent return coming up on a future mission where it doesn't matter because we're looking at bone, and bone doesn't change that fast. But of course, there are a lot of reasons to use animal studies to look at things like balance or sensory motor effects, and those are going to change so rapidly on return that we need to have the animals back right away. Also, cell biology, microbiology, plant studies, all of those organisms start adapting immediately on return to gravity. And so to be able to look at the genetics of what actual genes are being expressed in a plant when it's not in a gravitational field, to get those kinds of measures, you really need the samples quite rapidly. Another area that's important is there have been a number of studies where we looked at microbial virulence, and that virulence was maintained even when the microbes returned to Earth for a period of time. Some of that work was done on shuttle where we got the samples back within 3 to 6 hours. And so we haven't been able to reproduce all of those studies or extend them until we have this rapid return capability. So those are just some examples of some of the really high profile work.
Okay, next up we have Jeremy Cox with the Daily Times, and I'd just like to remind our phone bridge, please, just one question each for now so we can make sure everybody gets a chance. Jeremy?
Hi, thanks for taking my question. I was wondering if you could help me understand a little bit better how the Orbital contract will work between using the facilities in Virginia and Florida. Will those just be chosen, on a case-by-case basis, or what's happening there?
So the contract, the proposal by Orbital allowed a mission type, 3 different types of missions, but for pressurized cargo, they allowed a mission type that would launch from Florida on an Atlas rocket, or from Virginia, Wallops, Virginia, on a Antares rocket. And it's up to NASA to decide which of those vehicles. Now the vehicles have different capabilities, and so again, it's about what are our needs. They have different capabilities and different costs, and so we have the ability, as time goes on, to evaluate what we need and make that selection. You have to make that selection years in advance, according to the template. It takes a while to build and test a rocket before you're ready to fly it. So what we expect to do is evaluate that. Like I said, we're starting our assessments here in the very near term with these companies, and we'll look at what our requirements are out in those years and make a decision. But it may not be the same rocket and the same location every time. We might very well decide to buy a few flights from Wallops and a flight from Florida. We'll just have to see as our work and assessments with these providers continues.
Okay, next we have Dana Hull with Bloomberg News. Dana?
Yes, hi, thanks so much for taking the call. So since each company gets a minimum of 6 missions, is it fair to describe this as a straight 3-way split, or the monetary amounts could differ wildly? And I guess, part of the monetary equation is what the costs that each company bid. So I just want to make sure that I'm characterizing this correctly.
Yeah, the contract has a minimum of 6 missions per selectee. So in that sense, everyone is going to get the minimum. It is likely that we will buy more than 18 flights. So we have three winners, and if we need more than 18 flights, then we'll talk about what happens on those flights. So depending on how you're looking at it, whether or not it's a split. Also, the cost from each of the providers, or the price offered by each of the providers, was different. And so, the capabilities are different. It's really hard to go match up exactly, which one, is it an absolute 33% split? But from a straight minimum buy, you could say that, yes.
Okay, next we have James Dean with Florida Today. James?
Hi, thank you. Because the Dream Chaser has not flown yet, is it subject to any test flight requirements before it begins its contracted missions? And I also wondered if there might be any changes to the incumbent vehicles that would be noticeable, for example, something like Dragons landing on land instead of water, or anything like that. Thank you.
So all the vehicles are required to meet our requirements, and they're commercial vehicles, right? They're required to have a FAA license. And so do I expect Sierra to have test flights? Absolutely. But we're buying a service. Here are our requirements. They have to get an FAA license. There are their requirements, and so that's really how it's dictated. The biggest difference you'll see is, as I mentioned before, some of these are berthing missions and some of these are docking missions. Docking missions are really cool in the sense they'll fly up and you know, the crew doesn't have to operate an arm or anything like that to make them successful. It's you know, an automation task that has to happen, and that'll be really really cool. The berthing missions require ISS crew member intervention. They'll have to operate the arm. And so you might ask, well, why in the world would you ever select a berthing mission? It turns out the hatches are different sizes. And some of the cargo we have is really big. And so berthing hatches are very, very large, and we have the ability to move racks in and out through a berthing hatch. Docking hatches are really about the size of a human. So it's really, again, what do we need in terms of a mix at any given time for on-orbit ISS. As far as the details of the proposal of that about water landing, land landing, and so on, there are some that talk about a land landing, and I don't know how much detail we're allowed to talk about their proposals at this time. So let me defer the answer to your question here a little bit, and we certainly will provide it shortly.
Okay, next up we have Stephen Clark, Spaceflight Now.
Hi, thanks for taking my question. I was wondering if maybe Kirk could refresh my memory on how many flights have been awarded to SpaceX and Orbital ATK under the CRS-1 contract. Is it still 15 and 10 respectively? And do you expect to issue any more task orders under CRS-1 in the coming months to bridge any gap that may be between CRS-1 and the first CRS-2 mission? Thanks.
Let's see. So the answer to the second question is yes. We here in December signed a task order with SpaceX for a flight to bridge the gap, if you will, between CRS-1 and CRS-2, and we have a proposal in our hands right now from Orbital under CRS-1 for some flights that we're still evaluating. So the second question, the answer is absolutely yes. As far as the specific numbers, I don't have the data here, and rather than go from my memory, I'd rather I'll take a note here, and we'll get that answer to you here just a few minutes after we're done. It's public record. We'll be happy to provide that. I just, rather than quote it off my brain, I'd rather get you the exact number.
All right, we had a couple drop off the phone bridge, so again, if you do still have a question, you haven't asked one yet, please press *1 to make sure that you are in our queue. All right, next up, let's go to Khaled Henry with Via Satellite. You're up.
Hi, my question is about CubeSat launches, mainly from the International Space Station. That's been something that's grown in popularity recently. Does the new contract take into consideration at all requirements for satellite launches from the ISS?
Yeah, the new contract is silent on that, but today under the CRS-1, as you know, we're flying up deployers and launching not only CubeSats, by the way, we're launching other deployers. In fact, we just launched another deployer on the last orbital flight here that's currently berthed to ISS, called KBR. So yes, I expect that ISS will continue to deploy CubeSats and other small satellites. They'll be both for NASA research, but to a large extent they'll be for commercial entities through our national lab and cases. I expect that to continue and and to grow. But it wasn't directly addressed in this contract. It's one of our goals, as I mentioned earlier, to foster a low Earth orbit economy, and as we all know, CubeSats are a growing portion of that low Earth orbit economy.
All right, we're going to bring it back here inside the room real quick. We do have some time for follow-ups. I think, Robert, you had one real quick.
Robert Perlman with CollectSpace.com again. It was mentioned that under CRS2 you have increased mass on all 3 vehicles. Dream Chaser is new. Can you clarify the Cygnus is the same expanded Cygnus that just launched on Atlas that's on station now, and what does that mean for Dragon? Is there a new Dragon or a new cargo Dragon that offers more mass, or is it just taking advantage of more capability?
There was a minimum, I mentioned it, 2.5 to 5 metric tons of cargo that they had to meet in order to compete for CRS2, and all of them met that. So, and I would tell you the missions are different. For instance, Orbital ATK, their capability to lift from Florida on an Atlas is different than their ability to lift from Antares from Wallops, and so there really isn't a crisp answer to your question. The requirement, the Dragon that's going to go, they offered a mission that docks to ISS. So is it different? Yes, I expect it to be different, but that's the exact details of the differences is probably something that those companies ought to talk about.
Okay, and we do have a couple more that hop back on the phone bridge. Let's do Marcia Dunn with the Associated Press. Marcia.
Hello, for Kirk. Did I understand correctly in you saying that Sierra Nevada would have the option of launching either from Cape Canaveral or Wallops on the 2 different rockets? And does that mean that it will be just as flexible in where it can land on a runway?
So the Dream Chaser, the Sierra Nevada proposal launched only from Florida. So they did not offer to fly from anywhere else and anything other than a specific Atlas rocket. That was their proposal. I have heard Mark Sirangelo talk about the capability of Dream Chaser to land at lots of places. You can probably ask him about where it might be able to land, but I'm told it's quite capable to land in lots of places. For us, Julie likes her samples really quick, as you heard, and we don't have at the Dulles Airport, we don't have that many labs, so most likely it's going to land. And by the way, the air traffic controllers would hate us landing there. So, but what most likely will land in Florida, right close to where our facilities are. So let me not comment too much on the capabilities of that vehicle, other than to say that rocket's going to launch from Florida, and we're going to land it close to our facilities to support our research recovery on board from that vehicle.
All right, next up we have Ken Chang with the New York Times. Ken.
Hi, thank you. Kirk mentioned 4 flights a year, so from 2019 to 2024 is 5 years, and that's 20 flights in total. Is progress in addition to that, or is progress being phased out?
So I said approximately 4 flights. That's the beauty of this. Again, the vehicles have different up mass capabilities and different down mass capabilities. And so, number one. Number two is, by the way, the reason I said approximately, if anyone draws a 12-month period, depending on where the flights fall, it might be more or less than that. That's why I said approximately. I didn't want anyone to go beat me over the head about, hey, it's 5 flights and you said 4, or 3 and you said 5, and so in general we expect 4 flights. The Progress vehicle is the Russian vehicle, so the Russians have responsibility to launch their cargo, and so at this point in time the Russians continue to build and launch Progress as they've told us that's their intent. So I don't see anything happening with their Progress, and this procurement really has no impact on the Russian ability to launch cargo to ISS.
All right, now we have Frank Mooring with Aviation Week. Frank.
Thank you again. Kirk, I believe Sierra Nevada had a separate cargo module, kind of like a trailer behind the lifting body shape. Is that part of this this contract, and how would you use that new capability or planned capability? Thank you.
Yeah, again, let me defer to Sierra Nevada about the specifics of their vehicle. I can tell you that they have the ability to carry the required amount of unpressurized cargo, and so the pressurized cargo will go inside the pressure part of the pressurized part, and we have the ability to meet our unpressurized needs through their vehicle design. So, that's probably the most I could say at this point in time. It's a very capable vehicle, and we're really looking forward to having that in our suite of capabilities to carry cargo to the ISS.
All right, I'm going to bring it back into the room real quick for follow-ups. I think, Eric, did you still have one?
Yeah. So you talked about Eric Berger with Ars Technica, you talked about the landing capabilities of Dream Chaser, and you were going to probably put that back in Florida. The SpaceX and the Dragon, will that land somewhere? Will you have an expected location for that? And then how long, I think the 3 to 6 hours return time you mentioned in terms of getting samples was Dream Chaser. How long until you can get stuff off of the Dragon?
The Dragon right now, the proposal was landing plus 6 hours for early capability, which is not all of their cargo, but early. So we'll look forward to that capability. They have in their proposal, they had a land landing and a water landing. And again, it depends on the type of mission that we choose to buy. But in either case, we'll have the ability to have a 6 hour. I think the land landing, we actually have a 3 hour recovery capability as well. So again, I have to tell you, I'm really excited about the suite of capabilities that we have, and our ability to go select these different types of missions. It's really going to allow us to greatly increase our flexibility and our utilization of ISS.
Gina?
Choi, you're recruiting a new class of astronauts. What kind of message does this send to them about what they'll be able to do when they come to NASA?
Well, as we've talked about in this recruitment, there's a variety of vehicles these new astronauts may fly on. We certainly want them to fly on the International Space Station. And of course, we have a couple of U.S. vehicles in development to do that, as well as continuing with the Soyuz. And we have Orion in development. And this resupply is saying, hey, we have the capability, we've made all the plans to make sure that we can have a total of 7 crew members, 4 that would fly up on a U.S. capability when commercial crew is done. And so it's all part of the picture of being able to support ISS in the future.
We'll take a few more follow-ups from the phone. Let's do James Dean from Florida today. James?
Hi, thanks again. Mr. Sharman, would it be correct to say that these awards complete the fleets of vehicles that will ever visit the ISS, at least as currently anticipated with operations to 2024? Are there any others, domestic or international, that could come into the picture? Thanks.
Yeah. So domestically, I can answer right now. We have no other vehicles. We have the commercial crew vehicles. We have these cargo vehicles, the cargo vehicles under CRS-1. We have HTV, which will continue. Is also important ability for carrying cargo to the ISS, and they will continue, which is provided by the Japanese Aerospace Exploration Agency. So that is our extent of what's planned at this point in time. I really hate to use the word complete, because who knows what the future will hold. But that is the only thing we have planned at this point in time. As for internationals, the Russians have talked about a number of vehicles that they have plans to go build, and number one. Number two is the Russian philosophy has been evolution. So the progress that was just launched here at the end of last year was a new progress, and so I really don't want to speak for the Russians. There is a possibility there might be other vehicles from them, but you'd really have to talk to Roscosmos about the specifics of their plans.
Okay, now Irene Klotz with Reuters. Irene?
Thanks. Kirk, can you say anything about now why Boeing was dropped back in November? They were quite public about the decision. And any reason specifically for the delay in the first flights under the new contracts from 2018 to 2019? Thank you.
Yeah, relative to Boeing, I'm not sure what I can say at this point in time, so I'd rather defer that. At the right time, we'll be able to discuss that further, but we have to have briefings with all the offers, and so if I can, I'd like to defer answering that question, but promise to answer it in the future. Let's see, and can you remind me the second part of your question?
About the change of the target launch under the first CRS-2 contracts from 2018 to 2019.
Yeah, I'm sorry. Yes, the delay. So why? Well, we delayed this procurement a number of times. One, it was very complicated. We had multiple offers, as you know, and it took us a while to go. And we've been talking about the different mission types of the vehicles, and it just turned out to be a really complicated process. So the result of us wanting to take the appropriate amount of time to look at all the details and make the right choice for NASA, for the United States, that caused us to delay. And if you look at each contract, each offer says, hey, I need so much time to integrate, to do my ISS integration, and so much time to build my vehicles before I'm ready to fly. When you put all that together, it really puts them in the latter half of 2019. So the real reason for the delay was us being very deliberate and very careful, make sure we made the right decision, which you heard today, and that's caused us to delay a little bit when these first flights will fly.
Okay, we have time for just two more from the phone. Let's first go to Gotham once again with Cowan and Company.
Yes, thank you. I was wondering if you could comment on how dynamic pricing will be. For example, if you were to order the same mission from one of the contractors multiple times, would you anticipate that the price would step down over time? And as you issue task orders, are you going to compete them among the contractors and award them based on kind of best price?
The price of the various offers is really, at this point in time, we're not ready to release that. I don't know that we'll ever be. Some of that's competition sensitive. So, it's hard to directly answer your question. Plus, the fact that each mission type and each provider is different. There is not really going to be an apples to apples comparison. As we go forward and issue task orders to buy flights, first of all, we have a minimum requirement for each of the providers, so you can guarantee, we can guarantee that we will buy 6 from each one of those providers. Beyond that, again, and even within that, between now and 2024, as we're going to decide which type of mission do we need at any given time. So price will be a factor, but it's only one of many, many factors. And so I don't see it as, it's not like going out and buying gas from a gas station. You just find the cheapest one and go buy it. It's much more complicated than that. So, but price is absolutely a consideration. But really, like I said, it's one of 6 or 7 different factors, and not the driving requirement.
All right, and lastly, we will go to Ken Chang with the New York Times again. Ken?
Hi, thanks. I was wondering if you could give us a minimum value of these contracts by multiplying 6 by the cheapest option.
I could, yes, I could, but I won't. So again, I appreciate yours and others' eagerness to know exactly the price of each of these options, and that's just not information we can divulge at this time. I think the competition was very competitive. And as you'll see, the source, the criteria for making the source selection, price was a very important in terms of selecting these 3 companies and their offerings. But they're so diverse in the capabilities. The only thing I'll tell you right now is way under, significantly under the maximum contract value that I mentioned earlier. But I can't give you the absolute minimum price. That even implies that that it meets all our requirements, and the minimum price would not meet all of our requirements. So unfortunately, it's just, number one, I won't tell you the prices today, and number two, it really isn't that cut and dried.
All right, well, I want to thank everybody for joining us today, and thanks again to all of our briefers here for this historic announcement. Again, the source selection rationale and additional details will be released in the future at the appropriate time. Any follow-up questions about this announcement can, of course, be directed to NASA's Office of Communications. And you can read more about this announcement and the continuing journey of human spaceflight and NASA's mission to the International Space Station and beyond online at nasa.gov. Thank you for joining us, and that'll do it.